Hello everyone, and welcome to Handmade Hero, the show where we code a complete stream live on game. That's good. I don't know what that would mean. I guess we would like code some kind of streaming service while playing a game or something like that. What I meant to say was code a complete game live on stream, but apparently it's a very spoonerized day to day. Anyway, point being, today we are going to make some improvements to our debug top list, which our profiling list, which shows the top time takers in the game. And we implemented it yesterday, and we don't have like all the features that we might want in there, so this is the time for that. So that's what we're doing. If you would like to follow along, day 266 is the day to unpack. Day 267 is the day today. So do that and follow along at home. All right. So one thing I maybe do want to do, though, is because we indulged SSSSS McGrath the other day about executables that patch themselves, but I don't actually ever want that happening in Handmade Hero, so I'm going to go ahead and get rid of this because I don't actually ever want that to occur, but, you know, that's for the McGraths of the world to worry about and not me. So what I want to do is I want to go to our debug code and make some improvements. Here is the piece of code that I am talking about. If you see what happens here when we run, I don't actually want any of these breakpoints anymore. When we run, we end up in a situation where we can get this top list, but there's a bunch of things that the top list doesn't do right now. First of all, it looks like sprintf is wonky and isn't obeying our width specifications. So I don't know, it doesn't really matter because we can print these out in columns ourselves, so we could do that. The other thing is we're not constraining it to fall inside a window. So like if we, this is ostensibly the window for the top list, and it's not, we're just drawing, we're not even like paying any attention to that. So we might want to make some stuff for that. And then the other thing, and by far the more important thing, the one that I think we're going to start with first, is that as we are looking at this top list, we're actually seeing things that include their children. So when this says that it took 23 million cycles to execute, what that means is this entire block, including all the children, took that. But of course, game update and render is included in the game update block. So it's not a really very helpful thing to view because we want to know, the primary use for something like this is obviously twofold. One is to say, show me the breakdown of things in the program, but honestly, we already have a lot of ways. We can look at this and kind of see what's going on with that, certainly. So, we have a way of getting a rough breakdown over time and things like that. But, if we look at this, what we want to see is where do we go if we want to optimize? Like we're kind of just, we just want to see a thing. It's like who's taking the most time. And so showing me game update taking the most time isn't really very helpful because I can't go optimize game update. Game update is like 4 or 5 lines of code or something probably, and then some calls out to other code. And so what I wanted to know is what's slow in the other code. Like tell me where in the code I actually, tell me where I actually need to go optimize. That's what I want to know, right? So for the top list, what I'd like to be able to do is produce a list that has not just a percentage of the time total, but a percentage of the time not counting the children. So if something happens to take 22% of the time, but 21% of the time is actually in the children, then it's only going to show up as 1% of the time, well, that's not right, but you get what I mean. If something shows up as 23 million cycles, but 22 millionth of those cycles are actually in the children, it should show up as 1 million cycles, right? That's what I actually want to have happen here. So how can we do that? And I thought of some interesting things, by the way, after last night's stream, kind of when I, shut it off and went away. Some stuff occurred to me, and we'll maybe play with that a little bit as well, because there's some interesting stuff I thought we could do. But so what I want to do is extend the collation phase that when we're doing our collation, we actually are in a good position to compute stuff like child times, but we just don't actually do it, right? So we don't actually look at any of that information. So all I want to do is extend our thing by adding one 64-bit counter, which is the exclusive time. Actually, we don't even 64-bit. It's probably a 32-bit would be fine. because nothing takes 4 billion cycles by itself at the moment. But whatever. I don't really care about the memory. We can be picky. In fact, just to prove how piggy we can be, you know what I'm saying? So I don't care. So I'm just going to say that in here, when we create one of these profile nodes, we'll create a duration, and we'll just make 2 different kinds. We'll do duration including children, and we'll do, well, actually, we'll do duration and duration of children. Okay? And so all we would need to do now is, if we want to know the total duration, we just use it, as we have been. But if we want to know the duration without the children, we can remove this value. So we can just subtract that away. Okay? And so all we have to do to make that is, when we're actually creating one of these debug profile nodes, this is not the function. I actually want to be in here. All right. Yeah. When we're actually dealing with these profile nodes, when I first create one, so when we're doing the collation here, when I first create one of these nodes, you can see me doing that here, right? There's here and here are the 2 places where I do that. When we initialize the duration to 0, we can just also initialize the duration of children to 0. And so in here where we do duration of children, we now know that we start out with nothing in there. And if we come to something like an end block, where we're going to compute what the duration actually was, then at this time what I'd like to do is say whoever the block was that was above us, right? That profile node, I would like it to include this node's duration into that block automatically, right? Now, obviously, we could do this by just going to first child, summing up all the durations and subtracting them, but I'd rather just have it in one place. So I'm just going to do that while we go, right? Again, there's 2 ways we could do it. We could go to first child, sum them all up, and maybe that's a smarter thing to do, but I don't want that to have to keep happening, right? So I'm just going to have it happen right here. So the way I'm going to do that is inside deallocate open debug block. I believe what happens here is it pops the block, right? So if I go to, if I call deallocate open debug block, then this first open code block is now going to point to some other block, right? So if I check and say, okay, what's the new first open code block, assuming that there is one, I can then get out its profile node, okay? So here's the parent node for the node that I was in. It's going to be thread first open code block node profile node. That parent node, as soon as Alan gets better indentation support into 4Coder, I'm going to be so happy. I keep having to like undo indent things. It's one of the only things I notice now. It's that and the tab completion. Other than that, it's been like, yeah. I'm so looking forward to summer of 4Coder, by the way, since obviously Alan has to actually go to school, like doesn't have very much time to program on it. But I'm hoping this summer will be very 4Coder-tastic. Anyway, parent node, if I've got one, which I do in the case, you know, if this was true, that parent node, I know that the duration of children is just a thing that I can sum to, and I can add whatever the duration was of my node, and now I've got the child duration in there, right? So now I know exactly what that duration is of all the children. So if I want to change our top list to be exclusive of the children, I can do that trivially just by taking the duration and, let's go up here, taking that duration and subtracting away that child portion. So for example, if I wanted to do that in here, right, I could do, let's see, clocks without children. It's like Doctors Without Borders, only less altruistic. So if I want to do that, I can just say like, okay, and maybe I do like clocks with children. So that's clocks with children. Clocks without children is just you take the total number of clocks and we take the ratio of children out of it. And so I could just quickly change this over to, so, you know, now we're doing it without that. So now we're only going to look at the actual blocks themselves without their children. And you can already see we get, just from that, a much clearer picture of where our time is actually being spent, right? Because now we're not double, triple, quadruple counting cycles in our percentages. Now our percentages are actually showing us the percentage of time spent in a block uniquely. And so we can see that essentially, this is exactly what we would expect for the cutscene. Essentially, our code takes no time at all because nothing's happening. We're just putting a cutscene out to the GPU. So pretty much 100% of our time is spent in the debug system, which has a ton of work to do because it goes and does all this stuff and renders everything and does whatever, and in the graphics card, basically, like, which is either doing the rendering or waiting for the VBlank, right? If we now switch to actually playing the game, then we'll see a more balanced output, right? So now we can see that, okay, now in game update and render, we are taking 20% of the time, right? Still not much, because still, like, most of the time is being spent in other things, but because, you know, we've got, like, the debug system eating up a ton of that time. But you can still see, in general, you know, we're getting more reasonable understanding of what's happening here. So, for example, now that game update block, which is a nothing block, it's just on the outside, is down here somewhere. In fact, where is it? It's right there, right? It takes nothing, right? Remember, that was the top function before. It's nothing now. And properly, game update and render, which we haven't really spent any time putting blocks inside of to break down, is taking all the time, right? And we can see that begin sim is a similar thing where it takes a fair bit of time. So, you know, we might ask, why is game update and render taking so much time? You know, that's a pretty fair thing to want to know. And we could start to figure that out now, right? We could go into handmade.cpp, go into game update and render, and here is the code that we're timing. There's the timed function there, and you can kind of see all the stuff that it might be doing. There's initialization code there, and this sort of stuff. I would assume, actually, though, that most of the time is going to be spent in these guys, title screens, cutscene, or the world render. And we can, again, start to sort of figure that out. So if I went into world mode.cpp now, update and render world, I can make this a timed function just to confirm my suspicion, right? And I don't really remember how this stuff works. Do I have to give it a name? I don't, right? Yeah. So if we unpause now and start to take a look at what the new looks like, you can see, okay, as we expected, update and render world is taking 13% of the time, right? And so that's, you know, that's more what we would expect to see. And it's not game update and render. But game update and render, oddly enough, that doesn't really add up quite the same. Let's scroll back a bit. So game update and render is taking 11, I should put some commas in here, 11 million cycles for game update and render. But that's real weird. But when we move to update and render world, it's still taking the exact same number of cycles, but the percentage changes. Because the time changed quite a bit as well. That's real weird. Is that just because of all this extra stuff we have to draw? Oh, it's because it has to draw 2 of these. Because since we changed... Oh, that's hilarious. Since our system doesn't uses the GUIDs as line numbers, after we change that file, we get secondary stuff. That doesn't seem like a good thing. That seems like a bad thing. I wonder if we want to change that aspect of the GUID system in some way. I'm not sure. Like, you know, you saw what happened there, right? Where is that GUID system? Where is Mr. GUID system? That's in interface. So right now we uniquify things quite a bit. We use like the file and the line and the counter. And I wonder if we maybe don't want to use line anymore. I wonder if we even just don't want to use line or counter. If we just want to use name, it's hard to say. Like, I don't know how, it's hard to say how unique you want these things to be, right? And maybe the right answer here is you do want those things to be unique across reloads. And what we really want is when we specify a debug UI element, instead of using debug name, we just use regular name. Maybe that's the right thing. Since a UI element shouldn't get duplicated, I'm not sure. I really don't know. Like I said, that's our decision to make, but I don't know which we want to do. But certainly, like if I rebuild the game, I don't want to duplicate these. And so now they won't be because they'll be using their name more specifically, right? Okay, so anyway, like I was saying, if we want to investigate this, now that I figured out what was going on there, we can see that, update and render world is taking all the time, which is what we would expect. So what we could do is we could go into that function now and see what it calls world mode. We could sort of see what it might be calling and maybe test a little bit of these regions of code, because you can see all the code in here for the world stuff. And just so we can maybe figure out what it is that actually takes the time, so that we don't have to guess, right? So, we could go in and say maybe there's a timer in here. So that's the ground chunks happening. This is the controller stuff, which I don't think is going to be particularly unusual. Here's the sim stuff, but that's all pretty reasonable. This is the rendering loop, so this I could probably push and thing. It already says move this out into handmade entity.cpp, so we're already sort of thinking about that, but I'll put a time block in here, which is like entity render. And then we've got some residuals from when we're doing testing the graphics, but I don't really suspect that that's going to be a big deal. So let's go ahead and see where that leaves us. So right now we're spending 20% of our time in ground chunks on, right? Like, what the fudge is happening in there? That's probably just old residual stuff that we shouldn't even be caring about. I don't even want the ground chunks anymore. The design of the game turned out not to use them. My bad. But I'm just curious to know. So what is it? Is it how many? It's because there's so many ground buffers, probably, is what it boils down to. So if we just nuke this, because I want to nuke it anyway, we'll get a ton of speed back because this is all garbage, is basically what it boils down to, right? Yeah. Now we're down to just 10% of the time being spent in begin sim, and pretty much everything else is in the debug system. So that's better, to say the least, right? And if we take a look at and this is in debug mode, so we get a lot faster in release mode as well, but now that looks much better. So we've got the debug collation, the frame display, the game update, taking their time there. And if I look inside game update, I can see that it's pretty much all in game update and render, which is all in update and render world. So off we go, right? In here we've got begin sim. This debug system is amazingly cool. Come on, people. That's just so cool. God. All right. Yeah. This would be one of those things that I'd spend another month on, probably, of real time. Like, this is just, like, you could probably, this would be a cool product. Like, I could see selling this thing. Right? You just make a really great viewer for it as an external application. I mean, it's cool. This thing is going to be so, so cool. Anyway. All right, so because I mean, like, basically, like, with just a week of full-time programming time, think of how awesome you could make these windows, right? They're so zygotish now because I only have, like, I got 10 minutes here and there to, like, throw at, like, changing some of the rendering code. But if you actually spent some time on it. Anyway, so this stuff here is starting to look pretty good, and you can see we can already use it to find problems. We just found a huge problem, and we can get rid of that problem really easily, right? And this will continue to be true as we go forward. So that's all well and good. That's all fine and nice and dandy. So I think that's pretty much all I really wanted to do. with this window. And so mostly what I think I would do now, I want to just clean up the rendering aspect of it so that it's not, you know, extending outside of what the bounds are of it and that sort of thing, right? I think that's really all we need to do. And I'm not going to go crazy with it. Like, we could do a lot more fancy stuff here, and I won't bother with that. I'll just, you know, do sort of a reasonable pass. And then, gosh, I don't know what else we have left to do, really. Yeah. Anyway, so let's take a look at making this. We could do a sort of a poor man's clip to this thing if we wanted to. That'd be real easy, like without having to actually add the ability to expose the clipping rectangle. Do we expose the clipping rectangle from the render group? You know, we should have, but I don't know that we ever did, because we support clipping, but we don't actually. I don't know if we actually ever do that. So where's the clip rect? Yeah, so we never actually allow you to set that clip rect, which is something we probably should have done. So I'm just going to do poor man's clipping for now. I don't think this is enough of a reason to expose the clip rect API-wise. So we'll skip that for now. All right. Excuse me. So let's take a look at what's going on here. What I want to do in handmade debug.cpp in the top clocks list, I'm just going to say that, well, we're starting in the window and we're drawing, right? So here's the thing that goes through and draws everything, right? This is the text buffer. It just does like out, 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 right? All I want to do here is I'm just going to say, well, all right, I'm starting, you know, we've got this thing that starts at a particular at value, right? Here's the thing that starts at a particular at value. And if I just said, well, okay, I don't know, why do I always close the game, by the way? I always forget that this thing hot reloads, and it's like a force of habit. Anyway, you can see it draws off the end here, and the reason it draws off the end here is because it just blissfully, it doesn't ever check to see whether it's off the end, right? So what we could do instead is say that we only want to keep going in the case where the at y plus whatever the line advance is, we only want, oh, sorry, minus whatever the line advance is. So whatever the next line would be, we want that to be greater than the profile rect min y, right? We don't want to keep drawing if we get in a situation where we think we're going to be outside the bounds. Oops, I'm missing a dot there. And so now what you can see is it stops, you know, it stops actually drawing when we're outside the window in this direction. But it doesn't stop drawing if we're outside the window in the other direction. And similarly, you notice it sort of clears itself a little early. So we'll always get rid of the thing before it would have clipped at all. And we could make it a little bit better because actually we don't really care about this part so much. It's more like whether the baseline, whether or not we would be drawing, yeah, if we would be drawing such that the font that we're about to draw will go below, it doesn't matter where we'd actually advance to because that's actually too far, right? So in order to fix any more of that part of it, we would need to use the clipping rectangle. Now, maybe we should use the clipping rectangle. I don't know. We could. I mean, maybe let's take a quick look because it's probably something worth discussing, right? The other thing that would be nice is making this grabber handle bigger because honestly, I can never grab it. I always miss these days. It's too tiny. That's pretty easy to do, I suspect. That is in here somewhere. Yeah. So this thing, when it draws these guys, the size box is this thing over here. What I want to do is make the size box be expanded more. So I think this would be like an add radius to situation kind of a thing. So after I make this rectangle, oops. Give me an extra 4 pixels. Like, make the thing big, please. What are you complaining about? Ah, so you're telling me I can actually control it in both. Well, I don't care. That's all I really wanted anyway. And why did I close the game again? I always close the game for no reason. Anyway, now I've got a bigger thing to grab onto, which is what I wanted. So that's nice. So yeah, so that's all good, and we can keep that from drawing outside. If we want to take a look at drawing one more than we should have, and I'll show you what that looks like, and then we can take a look to see what the clip rec situation is. So all that would basically be is in here. What we would say is at y itself. Is at y itself below the min y level. Actually, no, that's not quite right, because we still might see a little bit of the font protruding. So we still want to do is at y minus, with the next one that we're going to do. Right? I shouldn't say the next one. I guess what I'm trying to say is as follows. All I'm trying to say is, here's our rectangle, and we're trying to draw inside this. We might have the pointer to at y, but whatever we're at, we're going to draw something, because, maybe the text is at the baseline. We don't know whether this is going to protrude up into here, right? So rather, what I would like to see is, I want to know if the previous one would have been there, right? If the previous one is here, that means the next one was here, and there's no way that we could possibly draw, because we know we won't draw above the previous. So I just want to make sure there's no chance that the line that we're currently drawing could have protruded, right? And so, after we advance, I guess what I want to do is say, well, in fact, I guess I could say something like this. B32 clipped. What I could say is clipped is going to be, is the current at y, the one before we do the advance, is it already outside, right? So is at y already less than the profile rect's min.y? If it is, then after the advance we would break, right? And in fact, I guess I could just do it here. I could say if the at y is less than the min y, then after the advance, we definitely don't care. So we'd just do end of the loop here. So now I believe what we should have gotten out of that is that this should draw a little bit outside, right? So you can kind of see like it always draws one past the one that's completely contained, which is what we want. Because once we put clipping in, we're going to clip out the part that you shouldn't see. And so we want to leave, we still want that to draw. Otherwise, we would leave like kind of an empty gap there instead of seeing a little bit of what comes after it, which is what I would have preferred, right? Okay, so clipping rectangles, adding those to our system, I don't really think would be particularly difficult. I'll show you roughly what that boils down to. So inside the render group, right, we kind of have this concept of a camera transform at the moment. And so what we can do with the camera transform is we could say, in addition to, in fact, we could also do it with an object transform, but we could do it in either place. We just say, in addition to telling you how we want to transform the coordinates, we could also tell you how we want to clip them, right? So in the camera transform, we could say that there's a rectangle 2, and this is the clip rect. And by default, that'll be set to the whole screen, but if you ever want to narrow that region down, you can. Right? And so any place that we were previously dealing with the camera transform, we would now want to set that clip rect. So, you know, camera transform, you can see them in here. Yeah, like perspective, orthographic, and so on. Right? The other thing, you know, to be honest, let me just think this through. Let me write the usage code first, because I'm thinking that I may want to track the clip rect separately for ease of use on the person side. Like I may want you to be able to like push and pop that. In fact, I probably do. So I think what I probably want is something like inside the render group, there's the clip rect. And the clip rect is going to have to get recorded. So essentially, whenever you push something on to the stack, it's going to have that in there. So when we do render entry bitmap or render entry rectangle, that's going to have to be included. So for rectangle, it's not such a big deal because rectangle we can just clip already. So we can just clip the rectangle and store the rectangle by itself. But for bitmap, we would actually need the clip rect to be set properly, if that makes sense. And the other thing I guess we could do if we wanted to, and I'd have to think about whether we want to, but one thing we could do is inside here, we could also make the clip rect be something that just goes into the stream. And I don't know how I feel about that, but that could be one way to do it that might be interesting. Where like essentially you know, that's actually one of the stream records is here's the new clipping rectangle. I don't know that I love that though. I think I would probably prefer it if that were not the case. Yeah, so I'm not going to do that. Okay. So what I want to do here, I'm going to do sort of the simpler method first, and then I'm going to do a more complicated method subsequent to that, I think. Because I think we should probably clean this up a little bit as well anyway. And what I would like to do here is just say, okay, we know that render entry rectangle could just be clipped directly. So the question is render entry bitmap. It can't be clipped directly. And the reason for that is that although it's got a P and a size, we don't have any way, if we could rechange that P and the size to still basically create the right rectangle pre-clipped and store the clipped version of it. What we couldn't do is say how the texture coordinates had to be offset to account for the fact that it got clipped, right? So, well, and I guess now that I think about it, maybe that's just all I should really store, right? Maybe that's the most useful thing to store. Like maybe the most useful thing to store is to store UV offset. And then what I can do is when we draw this bitmap, it'll just offset the UVs by that amount, and that'll be the end of it, right? So let's try that. When we do a push bitmap call and we write one of those things on there, here's our push bitmap. I'm just going to do entry UV offset, and that UV offset I'll make be 0, 0. Now what I need to do is first we have to do the OpenGL version, right? Because we have two render paths now, both of which would have to be correct. So when we render a bitmap and we call OpenGL rectangle, you can see we've got the min UV and the max UV like so. And so what I would want to do here is I want to offset those by whatever the offset actually is. And I think that should be relatively straightforward. Now the only question is, should we record the offset in the textile space? You know, what space basically should we encode the offset in? And I feel like probably what we want to do is encode the offset in pixel space, to be honest. That seems a little more sensible to me. And in fact, if we wanted to, we could maybe make this a little bit more sensible by doing like, you know, something like this. Where we just, because we know that we can't have any bitmaps that are greater than 64K wide or tall, what we could do here is say, well, all right, you know, we create our one texel thing and we create our min UV and our max UV that we're drawing for the rectangle. Well, now once we have this rectangle, we just need some information about how that's going to get clipped. You know what, now I think about it, that's not enough information. Because I'm thinking about clipping off of one side, and we don't really know that. So we'll probably have to actually store this as a real, more as a real rectangle. Because essentially what'll happen is, what if we have a clipping rectangle, you know, that's like this big, and the thing we draw is like here? An offset's not going to do it. So I think we're going to have to store this as a real thing. So that's fine, because this is not a particularly good way to store this anyway, to be completely honest with you. You know, because we're basically doing UV rendering, it seems like it would be way easier if when we do a bitmap that we render, we store enough information to actually do all the stuff we can do. Like, for example, this doesn't even have rotation in it, right? So our thing that we're pushing on here doesn't even support some of the things that we can actually do. So I think it might be more interesting to say, all right, if we're gonna like make this more real, let's actually make it more real. So what would we need in order to do the full version? Well, we could do something like a base P, right? Where we store, you know, a corner. And I guess maybe I'll draw this out so everyone's on the same page. The way we were doing it before is we kind of had like a base P, and then we had, you know, a vector here, you know, and a vector here, and this sort of filled itself in, right? And that could be a reasonable way to go. It's just a little overspecified. It allows you to turn this sort of stuff around when really you normally wouldn't be able to. Like, you know, it allows you to squish things in a way that we don't really want to support probably, because it'll create weird artifacts in how the texture's interpolated. So we could do something where we have like a, you know, a vector here and a vector here. And you know, we might want to support non-uniform scaling, so we may need like just one of these and then a multiplier for this that says how big this one is, right? So it would be something like a p value, you know, an x-axis, and a y-axis coefficient. And so you just, it's just the perpendicular to the x-axis, but then it's multiplied by this to allow you to do non-uniform scale, right? So that would allow us to do any rectangle we wanted, but it wouldn't allow us to say what part of the bitmap we actually want to show in there, right? And furthermore, if we actually allow this rotation to happen, like this makes it so that we can't actually clip it right. You know what I mean? So this kind of makes the problem of, well, if we wanted to clip it like this is no longer a rectangle. So we would actually have to do the clipping ourselves, which we probably don't want to do. So that, now that I've worked it through, pretty much answers the question for me. I think what we would want to do is have the clipping rectangle stored as part of the stream so that you can just set a clipping rectangle, dump a bunch of things in, and then unclip. Because otherwise I feel like it's just going to be too much data stored per bitmap entry, and if we want to increase the throughput of that, if we want to make it so that we can push a lot of bitmaps, it's just going to become a problem. So I think that's probably what we would want to do. So that means I can hold off on editing this at all at the moment, and but we will want to do that eventually, I think. And what I'll do here is say that there's a render group entry type, render entry clip rect. And so inside here, we just have a render entry clip rect, like so. And the render entry clip rect is just going to be what region we are allowing at the moment. And that should probably be, not sure exactly how, I suppose these should probably be in pixels, because I believe everything we store is currently in pixels. So I think we want to just do a min and a max And probably we could just do it as a rectangle too, right? Like so. Could just call this clip. And so that would set the clip rect specifically, and that would be all we would have to do. So if we're going to do that, all of this stuff stays the same. The only difference now is when we end up with one of these render group entry types, render entry clip, then all we have to do is say, well, oops, whenever we get one of these, we read it out. No, see, this isn't going to work either. This is really tricky adding clip recs in here. The reason this wouldn't actually work is because the render groups get sorted. So we really do need to know per entry what the clipping is, because they get moved around in order to depth sort. So we can't do that either. It seems like we really do need one per bitmap if we wanted to support arbitrary clip regions, which is pretty nasty. Although I guess it doesn't really matter that much. A modern day GPU probably doesn't care, and our software renderer certainly doesn't care. It's just more traffic. It's just a lot more traffic. I don't know, folks. Maybe someone out there has a bright idea. I mean, it could be that, you'd want to re-architect the rendering a little bit if you really cared about clip recs a lot. And I don't know. And it certainly seems like a waste, right, to have a ton of clip rect information packed in here for no real reason. But on the other hand, like I said, I'm not sure how you get around that if you want to do a renderer that does sorting, which we do. Well, I guess we'll just do it this way for now. And, that's how that'll work. So inside here, in render entry bitmap, I guess what we would have to do for every bitmap that we output, we'd have to check the clip rect to see whether or not it needs to change. I guess one thing we could do to make this a little bit better is have the clip recs actually just be indexed and then check the clip rec index to see if it's changed, and only if it's changed set the clip rec differently. And in fact, you could do it like this. You could do something like this where every header has a clip rect index. So when you come off the header, you would say something like U32 clip rect index equals 0. And then we'd say if header clip rect index is not equal to clip rect index, then we actually do it, right? We actually set the clip region. Let me actually phrase it this way. So if the clip rect index is equal to the one that this header wants, then we don't have to do anything. But if it's not, then we do have to do something. So let's do it. The other thing we could do is we could make this so we don't actually expand the size of these either. We could do this, right? Because that would be totally fine. And so that leaves it as still just one D-word entry. So we don't expand the traffic on the group at all. So assuming that it's not, what we need to do here is we need to call GL scissor in order to sort of restrict the bounds of what's going to happen. Now, you haven't seen GL scissor before, I don't think, because I don't think we've ever called it. By default, it will just be set to the right thing. So let me show you GL scissor. I never remember OpenGL, there's like a docs.gl. I was like, there's a place that people said to go that has prettier docs for us to use. I think this is it. And so GL Scissor is the way for us to, and I guess we can just look at the old style. Yeah. GL Scissor is a way of saying exactly what it is we want to say. It's saying, let's set the region that we're going to draw inside of. And by default, it's set to the whole window, but when we want to restrict the window, this is the way we would do it, right? And so all we need to do is pass it those bounds, and off we go. So I'm going to say that in addition, when we have our thing here where we've got game render commands, that game render commands, which I believe is in the platform thing, that game render commands, in addition to the push buffer base thing, it's going to have some number of clips, like clipping. What's what I'm looking for? It's going to have some number of clip rectangles, and that needs to be specified in here. So in addition to all this stuff, there's basically a thing that's like, you know, clip rect count and a some kind of a guess, I don't know if we want to specify this. I don't think rectangle 2s are actually specified here, right? But what we want to do is have a thing that's like clip rects, right? Something like this. And so that gets passed through, and that's how that gets rendered. Now, yeah. So I guess we could do something like this. Struct game render clip rect. We could do something like that, right? Or something of that nature. So that would pass these through, and then what we could do is say, all right, let's grab whatever the clip rect is that's the new clip rect we need out of this thing. So this is the new clip. So we're going to take our commands, clip rects, oops, and we're going to add to it whatever the clip rect index is. Then we're going to do GL Scissor. And what we can do is make this clip rect basically be exactly what we would pass to one of these things. So, you know, something like that. I don't know, we can change that, doesn't matter. As long as we can translate it into one of these calls, we're fine. So that'll go through and that'll set the clip rect accordingly. And another thing we could do, I suppose, is say that clip rect 0, yeah, well, I mean, we just say that clip rect 0 has to be the whole screen. That way, on entry, we can just do the... Well, you know what we could do, too? We don't even have to do that, now that I think about it. All we have to do is set clip rect index to something that isn't possible. Right? So if we want to, we can set clip rect index to something that can't possibly be true, so every time through we'll set it. We probably also want to assert that the clip rect index is less than the number that they say we have, so that we can check for out of bounds accesses there where somebody's passing a bogus clip rect index, right? But that's about it. So if we go with that, so now we have a little thing of clip rects. Anyone can reference a clip rect, and off we go. Then I've got a bunch of changes now that I need to make to support that. So we know that this is going to be a U16 in here. That's all fine. I guess what I should also do is when we do that push render element, I'll do clip rect index. And that clip rect index will be like the group current clip rect index or something like that. And that should be sufficient, I think. So yeah, we'll say that. We don't have that yet, and that's fine. UV offset is nonsense. We got rid of that. And so now in here, we need this thing to actually exist. That can be in render group. So our render group can have this thing here that we call a game render clip rect. It could just be called a render clip, but since it's exposed externally, I called it that. Don't ask me why. I don't know why. That's just this stuff, right? And that's it. So we're basically, done with the actual support part of it. But what we want to, and we now have to go through and actually do some of the, clean up some of those details, right? So now we need a way for people to actually specify these things. So inside the render group, we have to have a thing in here which is like current cliprect index. And that current cliprect index is going to have to get initialized to 0, right? So when we have like the generation ID or whatever getting set here, and we initialize this stuff, like here's the begin render group stuff. In there we have to do current cliprect index equals 0. And we're also going to have to do a push. We got to push data onto the push buffer, or we have to reserve some room for actually having, some of these cliprecs. Like we need an actual array for them. So we've got a game render commands thing, but I'm not sure who actually, where we actually get the clipdirect stuff from. So when we actually push, who pushes? Where do we push when we push a render element? So when we push these on, we just use the push buffer base plus the push buffer size. So we're just kind of putting it onto the end of the push buffer, right? So nobody allocates any memory. It doesn't use an arena or any of that stuff. It just does the pushing manually, is how that works, right? Which doesn't make a whole lot of sense. I don't know why we didn't bother just using the arena. Maybe we wrote this before the arena, I'm not sure. Doesn't really matter, but point being, that's how that goes. So what we could do there is we could say that when we initially get the push buffer, we push one on there. Or what we could do, we could even just hard code the limit if we wanted to. I don't know if that's a good idea, because we probably want to support an arbitrary number of clip rectangles. So I'm not sure what the best trade-off is here. Ideally, I'm having a thought. And it's kind of crazy, but I had it, so here it comes. You ready for this? Because it's banana cakes. So what I want to do is I want to support an arbitrary number of cliprecs up to the amount that would fit in our push buffer space. So if we have, a big old hunk of memory for the push buffer, if you want to use up some of that for generating cliprecs, I want that to just work. So what I'm going to do is I'm going to say, well, okay, I'll give you a for instance here. Let's suppose we have an actual pushable push rect. So, a clip rect. So like I said before, we actually have one on here. And this is a record of a clip rect. And the cliprect stores an actual game render cliprect, that's the data, and then it also stores a render entry cliprect that's whatever the next cliprect is. Okay? So that means in here, when we do current cliprect index, all I would say is, all right, I'm going to do a push render element. I'm going to do a push render element, or rather, I'm just going to do a push clip rect, right? And in fact, I guess I'll do it this way. I'll say push clip rect. I'll do push clip rect, and the push clip rect will be the whole screen. I guess one problem here is I don't really know what the whole screen is quite yet. That's a little dicey. I admit that. Let's go in here and deal with that for 1 second. Okay, so this is the first place I could actually do this. right? So once we're in here, I would have to do something like, okay, the render group at this point can do the actual operation that I want once it gets to this point. So I can push a clip rect on, and the clip rect can be the entire window. Okay. So that, I think, is what I want. And in here, in addition to current clip rect index, I need another thing, which is that total or clip rect count. All right. And now I think I'm done. So here's the way I think this should work. When we actually do our pushes of things, like up in here where we have like push this, push that. So here's like a push rect call. Up where we do our push rect, we're going to have push clip rect. And that's not going to have any transforms or anything. It's just going to have what is the region that you were expecting to clip, right? Although I guess if I wanted to, I could make it so that they go through the transform. I guess why not, now that I think about it. So I could actually have one of these. But then I will also have push clip rect that does the direct one. So this one's just going to be like, you know, so when I push the render element, I'm going to get back a render entity clip rect. And I don't care what the sort key is. The sort key can be whatever. It doesn't matter, right? The sort key is irrelevant, and I'll show you why in a second. So what I'm going to do is I'm going to push this on there. I now have a place to record the clip rect properly. And in here, I will track where the last, whatever the last one, and wait, I don't even need that. I'm an idiot. I don't even need that at all. In fact, all we need is this. We don't even need the entry. This is getting ridiculous, how crazy this is going to be. We don't even need this at all. That's not there. So I could actually, I guess I could say, let's call this, let's not call it that anymore. We'll literally just make it be one of these things. Okay. So we're going to want to push on one of these render entity clip rects. So here is us pushing it on. And then once we have it, we just set the x to the x, and we just truncate the values, right? Because we know that the screen can't be any bigger than that. And so we're just going to assume that that's fine. Like if you were actually setting a clip rect out in the middle of nowhere, you wouldn't see it on the screen anyway, and so we don't care if the values got truncated. In fact, that's just an error. I don't even care. So when we call push clip rect, we put that on there, and we don't care anymore. Now, the one thing we do care about is that this clip rect has to have a number, so every time we push one of those on, we have to go to our group clip rect count. We need to know what the clip rect was. So we have a result value. That result value is going to be whatever the clip rect count was. So the only thing I really need to do here is store these two things. So we store, you know, we say whatever the one you pushed is, you get back that one. So the first time you push it is clip rect 0, next time is 1, blah, blah, blah. So that happens. And anytime you want to push a clip rect on that obeys the object transform, you could do that as well, like so. And that'll just follow our same path. So you push a, you push a P on there, And yeah, you get back all the rest of this nonsense, and then you just say, all right, we've got the rect, the entry basis, the p, and the dim. So all we would need to do now is translate those into integer coordinates. So in here, what we would do, we wouldn't ever do this part. We just, once we determined that the basis was valid, we would do the push clip rect with the actual values that we computed. So it's like p0, round real 32 to int 32. And so all we're going to do here is just, oops. All we're going to do here is just round these guys out. So we got p0, or I guess we could say px and dimx. Typing troubles. And py and dim-y. And that pushes the clip rect on through a transform. So if you want to use the standard notation that we've been using, you can get that transform as well. All right. So whenever you're actually doing stuff, you can do your clip rect index nonsense. And obviously, these things are going to have to be truncated. We can assert here. In fact, we could do a safe truncate to U16. And that way it would assert for us where our there we go. Okay. So this would take a UN32, and it will assert that it's less than the maximum value for the U16, and then it would actually convert it. Right? Okay. So, I don't know why that's a result in there. So now we have the ability to push the clip recs on. I'm over time, aren't I? I should take the piggy hat off because I'm not really being piggy right now, to be honest. All right. So we've got the two push clip recs. And what is the... These guys are basically correct except for the fact that they don't have the render group. Under the head edit, right there. Didn't even need to see it. Game render clip rect unknown size. That's true because this now no longer a thing. This is actually render entry clip rect. Here we go. And the platform code, wherever that is happening, is actually going to be render entry clip rect. All right. So now I think we're almost there. The only thing that we have to do is the weird stuff that I was alluding to where I was like, this is going to be crazy. So what I've done is I wanted to make it so that any time during the rendering, you can just record a clip rect. So that's what we do, right? Anytime there's a clip rect comes in, a new one, we stick it in the render entry, like we stick it in the push buffer as everything else is going, right? And we remember what number it is, like which ordinal it is, so that we can refer to it, anyone who wants to clip to it, right? But the problem is now, what do? We need an array of those that we can access, do random access to really quickly, and we want them all compacted together so they're nice and fit in the cache, and we can just grab them out really quickly as necessary, like we want it all nice and whatever, right? Well, hey, guess what? Actually, when we are doing our rendering, you can actually see this stuff occur, right? We loop through and we do our entry sorting. That stuff actually has to go through all of the entries to prepare them for that, right? I mean, we had to actually do that work at some point, I believe. I could be wrong about that. In fact, maybe this is not as smart as I thought it was. Because do we actually build those simultaneously? This is going to be a big letdown. Yeah, we do. Oh, that's so sad. So we put the sort at the end. Well, it's not really that big of a letdown, I guess. It just means I have to use the next pointer that I didn't really want to use, right? I was hoping that I wouldn't have to do that, but I did. It's not a huge deal, but I thought it was going to be cooler. It wasn't as cool as I thought it was going to be. Whine. All right, so when we do an end render group, I guess it just assumes that the commands are correct. When we go to render them, it's going to have to do the sort, right? And so who actually does that op? Tell me who does it. Inside render.cpp, when we call render commands to bitmap, who actually does that? So win32 handmade.cpp. So it's right here. So you can see we generate the render commands, and then we come out of here and we do the audio, and then finally at the end, here it is. So here's the bit that does that rendering. So you can kind of see here we come through and we make the sort stuff. We call win32 display buffer in window. And so this stuff right here is either going to call OpenGL render commands. So its sort entries right here does the sort. And what sort entries, just like what sort entries does, we can do the same thing with the clip recs. So basically what we do is say, okay, there's sort memory, right? And there's clip rec memory. And we need to just linearize our clip recs. So we need to do like copy clip recs. Right? Or linearize clip recs. So that would pull them out and put them into a buffer that can hold them in a linear fashion and be done. So yeah, win32 display buffer in window. This is basically the exact same stuff. It's probably something we should make a little bit more carefully, meaning this should just be probably utility, because this is just going to get copied exactly, and that's probably not so useful. In fact, I'll do so really we just needed clip memory. I spelled it wrong. There we go. So this is going to give us the memory that we need. And all I really need here is I need to have a variable to store that. So in addition to the current sort memory, right, I've got the current clip memory. And yeah, those are adaptable. I don't really know why. At some point we could probably say that they're just not, but you know, for the moment they are. And if we didn't need to sort, I guess they wouldn't have to be. But then when we come in here, we just pass the clip memory in, and that can linearize it. So I suppose the other thing, one way of avoiding having to do all this was I could have made it so that each one of the headers has a pointer to its clip rect. The problem is I just felt like that was really adding way too much data to the system at that point. I don't know. Like, it may be that was a smarter way to do it, that you just point back into there, but I don't know. That's just what I, just sort of my gut feeling on that. So yeah, so hard to say. But anyway, sort entries. Here is our linearize clip recs. And all this would do is exactly what I just said. So it's just going to take essentially like a pointer to the game entry clip rect version, and it's going to walk those pointers, right? So it's going to go like, okay, game entry. Like so. And it's going to take and it will overwrite, well, not really overwrite, but set in the first place. This pointer where is it at? It'll set this pointer to point to it. So the commands clip recs, I guess at the outset, in fact, you could do it this way. So it starts off with a pointer to one of these things. It loops through them, and essentially what it does is it takes them and just linearizes them into a flat list. That's it, like so. And that's it. That's the entirety of that. So it's just taking them, they're spread out in the push buffer, it compacts them down into some temporary memory that it can use as a lookup table. And it's a little picky because now we need that next pointer, which I didn't actually want to put in there. We can strip that out when we do the copy, but I won't have time to do that right now. So we could do that later, but at the moment we can't. So render entry clip rect needs the next pointer in there, like I was saying, and that also means that the render group needs to track those. So the render group needs to have a render entry clip rect, first rect kind of a thing. And really what we'll do instead of actually keeping that is it'll be in the render commands effectively. So since multiple people can write to this, I think these actually also want to be in the commands only, is the other thing. So I think inside the platform struct, since multiple people can open and close this, the clip rect count needs to be kept entirely in here. And this probably, since we don't super care how big this struct is, it seems maybe I'll just expand it to make it a little clearer, and that way there's no confusion. So in here we'll just say, okay, we do first rect, and off we go. This stuff all works exactly the same way, and this sets that memory up properly. And so then all I really need to do now is I just need to track this inside render group. So inside render group, when we actually set these up, when I do a push clip rect, in here, this is actually going to be looking at the commands, and it's going to get the clip rect count out of there. And similarly, it's going to do the daisy chaining in here as well. So the rect next pointer is going to get initialized, and we're going to do a standard W linked list on this guy. So the commands first clip rect, so let's do last rect. We're just going to check to see if there have been any yet. Then we just chain it onto the end. If there haven't been, then this becomes both our first and our last. You've seen this pattern many times. This is just a singly linked list that keeps a tail pointer. And that should do it. Now, this should not actually use these at all at the moment. And I suppose we're probably not actually using... Oh, my bad. Wrote that code incorrectly. So this should actually be that. So yeah. This should not do anything at the moment. Yeah, so inside our processing routines in OpenGL render commands, we want to skip these guys. So I'm not sure what the best way to do that is. We just don't ever even want these entered into the sort stream. So really all we would do, all we want to do is just push some space on for them. And so I might actually not call the push entry stuff, because now that I'm not doing the little trick that I was saying that I was going to do, what I want to do here instead is just say like, okay, instead of calling push render element, I probably just want to push, I really just want to do this, just this operation here, right? So I want to do no header, there's some interesting stuff too that we should think about now that I'm thinking about it too. I wonder if we might want to play with the renderer a little bit next week. Now that we go through those sort entries for everything, it would probably make more sense for the sort entry stuff, since we're doing the sort, to put the type field out in the sort entry. You know what I mean? Because you could put the type in like the top 4 bits of the index, and then you wouldn't have to jump in and then look at, you wouldn't have to do the read and the look. That's just a, it's things I think about, sorry. So like the sort entry, we could do, get rid of this, the header could not bother storing that, right? So we could do like to do Casey, don't store type here, store in sort index. Something to think about. Anyway, so in here what I was thinking is, if we were to do a render entry clip rect and grab one of these guys, and don't bother initializing any of this stuff at all, and we don't put in one of these, so all we would do is grab some of the space. So literally all we're doing would be guarding against overflow, right? So I just want that. So assuming we can fit this thing in here, the size is obviously going to be the size of the render entry. Oops. Assuming that this can fit, that's all we need to know. And then we've got it. And everything else would work as normal. So yeah, and I guess we do group commands, game render commands. And this needs to be cast. Now, I think that should remove them entirely from that list. And so now we should be indexing into our cliprecs properly, which means we could add more of them if we wanted to, right? I literally have 2 minutes left, so I don't know that we'll have time to do any of that. But if we wanted to try it, we could try pushing cliprect on here just to see if it did anything. So if I was to say go in here and do let's say, where's the push rect? There it is. So if I was to do a push rect call that just took a rectangle, so like this case, so we'd do push clip rect, obviously these things don't have a Z to them, not any one that we care about anyway. Oh well, I guess they do, because they could be sized if we wanted them to be. They just don't have a color. So that would allow us to push a clip rect of a rectangle. So I could try making that happen. Okay. Yeah. So now inside debug.cpp, if I wanted to actually do one of these push recs, I could try. I'm sure it won't work, so we'll have to debug it tomorrow and actually make it work. But what we would do is when we come in here to say draw top clocks list, what we would do in here when we actually create this element rectangle and we do the push rect for it, for the backend transform, we would then immediately set the clip rect. So we do push clip rect, and I think that's, yeah. We do a push clip rect, and for now we'll just do it manually in place, but we'll make a little utility for this in a second. But we'll do like old clip rect, and this will be our render group current clip rect. And then we'll say, okay, the render group current clip rect index is going to be this new clip rect, which we will push. Here's the render group. We use exactly the values we're using to draw the rectangle. So we want to basically clip to the same thing that we've got, right? Doesn't need a color. Like so. And then we would just restore it afterwards. It's like a push and pop kind of thing. Uninitialized variable. That is true. How did that end up happening? Did I accidentally delete something in there? Where are you at? Oh, it's because this is actually a different dim. So it's that dim, and then this is like, this is the basis dim, dim B. Thank you, compiler, that was handy. So yeah, so that's where we're at the moment, and like I said, we're not working, right? Because this, if we were working, that would clip, right? So we would see like that right there would be clipping properly, and at the moment it's not. So that's what we can debug tomorrow, and we can also do questions. Maybe I'll do a couple questions, but we probably don't have very much time for them. So we can do questions on all of that stuff as well. So we can see in here when we do have our clipping, right? Let's see what the clip actually is set to. That's the full screen, which is what we might expect to see. We then come in with a different clip rect index of 1. It's also the same though. So here's one that's trying to clip to something else. Oh. You know what? We never enable GL Scissor. So GL Scissor is one of those things that doesn't actually take effect unless you enable it. So when we do our enables and we set up our like initial state, we never actually handle that. So maybe it might be scissor test. Yeah. Maybe that will clue us in a little. Hey, look. So actually that whole thing did work the first time, which is ridiculous. But hey, there you go. So now we have clipping, and the only thing we aren't that we would need to do tomorrow then is make the software renderer obey it as well, right? So in here, if we do the platform control, so if we switch to the software renderer, what the heck? Oh, right, because the GL Scissor is still enabled, right? You can see that it's not actually doing it. Let me fix that one. Excuse me. When we do OpenGL blit to screen or whatever it is, OpenGL, this needs to GL disable GL Scissor test, because we don't want that test enabled when we're doing that. My point was, if I go in here and I set it to the other renderer, you can kind of see how we don't clip anymore, right? So our software renderer isn't properly clipping to that region, and that's because we haven't told it about it. And maybe I should just go ahead and do it because I'm kind of in the mood. So when we do render commands to bitmap, right, and we do draw rectangle, you can see that we pass the clip rect in here, right? So we are oftentimes passing the clip rect. You can see the clip rect getting passed, but the clip rect is not actually being used, or rather, the clip rect is only being used for our tiled renderer, but we're not actually ever updating it to anything different. So we could call this our base clip rect if we wanted to, for example. And then what we can do is every time we get the header, we can do the exact same thing we did before, and instead just take our actual clip rect from the base clip rect, keep the same exact thing we were doing in the OpenGL renderer, where we said like, hey, as we go through, anytime you see in the header a different clip rect than the one we had, what we'll do in that case is we'll just update the one we have. So instead of making some call to GL to update the clip rect, we'll actually update our clip rect instead. Now what we have to do that, right, because we've got an existing clip rect that's the tiled render region. Remember, we render the screen in our software renderer in tiles so that each thread can render a different tile, right? So someone's rendering this, whatever. So we need to clip it to this, but now we also have some clip rect that's specified for the actual rendering that's been specified. So what we need to do is we need to intersect these two regions, right? So what we need to do is say, all right, what we want to do is whatever the clip rect that's coming out of this thing is, right? This thing here. we want to do an intersection of those. Now is rectangle 2i, we could just use these rectangle 2i's. And look, we already have an intersection. So I'm going to do that. So I'm going to say, okay, our clip rect is just the intersection. I didn't even know we had rectangle 2i's in this code base. We're going to take our base clip rect and we're going to intersect it with the one that's coming from this thing. Okay? And that's what we're going to do. So I'm going to say that. And what's going to happen here is we're going to have to change, because I would rather do it this way. We're going to change our render group stuff to actually use rectangle 2i in here. Like so. Okay. And so in here, what I'll do is we have our rect, and our rect has a min, like so. And all this is going to be is us just taking exactly the same values that we had before and encoding them slightly differently, right? What is rectangle 2i then? Math.h. Oh, so we actually just stored them directly. Okay. And so then all we have to do is translate the GL scissor to that. So min-x and max-x are, and min-y are the same, but the width is now encoded differently. So we'll have to compute that by taking the max-x and subtracting the min-x. Same thing with the y. So now let's check to see to make sure I didn't mess up the OpenGL renderer by switching that to that. There we go. And now let's go back to our software renderer and see if that works now. Hey, look, it does. So there we go. Now we've got clipping in both renderers, and everyone's happy. I will take the briefest of brief Q&As. I wonder why debug end takes so much time. Shouldn't the time be taken in debug collation? I guess I don't know exactly what's happening in debug end that would make it take more time, but... Oh, wait, no. Debug end has a draw. It's doing all this construction stuff. Popcorn OX90. What are top 3 reasons for FPS to go down? What do I don't know. What do you mean? You mean across all games ever, or what? Son of the right. Will cliprect be used outside of debug, and where? It might be like, I mean, I don't know, but it could be used in the game somewhere. It depends if we upgrade our render at some point to do fancier things like maquettes and stuff, where we might want to limit the region that's rendered because we're rendering some stuff that's going to get composited or whatever. Even if we didn't update the renderer, you could imagine, like, let's say that you're rendering, there's like a hole in the floor and you can see down to something else. Well, rather than render the whole thing behind there and then render the thing with just the hole in the floor and it like overdraw the whole screen, you could clip out those regions for efficiency, obviously, but. Can you elaborate on the ODE you plan to replace your drag function with in Move Entity? Not at the moment, obviously. That's a topic for when we go to replace it, and I'll show how to derive it and so on. Fucon, how about making the top list scrollable? Since now we clip it, it can be painful when you start profiling a lot more. So we could do that just as an exercise in how to make something scrollable, but in truth, we only ever care about the top couple entries anyway. You never care about anything that's down here, right? I mean, maybe in some academic sense you might, but for the most part, it's just not relevant, right? So what actually happens is you only ever look at these things, because these are where all your time's being spent. So you don't care. Anything that's below 1% is so irrelevant that you just don't care. Blah238, when does clipping overdrawn areas cost more than just drawing them? Never. It never costs more. It can only not save you time. But it never costs you more because everything always has to be clipped anyway. It has to be clipped to the screen area. So narrowing the clipping can only save you time. You don't ever, you always had to still clip. In certain older, in scenarios that that don't bear much resemblance to how we render things today, when clipping was more about doing geometric clipping on stuff, then it's possible that it could be more expensive because you subdivide more triangles more times. But that's very unlikely in the way today's renderers work. But in the old days when you did a lot of geometric triangle clipping, having to do all the clipping for the triangles could have been more expensive. Obviously, that's not so relevant in a thing where you've got a bunch of rectangles, but imagine like a 3D, in more of a 3D rendering kind of scenario. SSS McGrath, that's not entirely true. The state change on the clip isn't free, and if the size change is minor, it's probably not worth it. Yeah, I guess that's probably true. Like, if you were literally clipping rectangles all the time for no real reason, then maybe just the traffic of like, hey, I had to like update these 4 registers, on the GPU, or not registers, but these 4 entries in memory on the GPU or whatever, that could be something you might care about. When you switch between the renderers, the viewing frame time is obviously affected. Are the clocks in our newly clipped box also affected by the renderers, i.e. order distributed differently? Yeah, so, I mean, first of all, one thing I probably should do, we haven't tested it in a while and I should probably do this, is, if we're looking at profiling data, generally you wouldn't be looking at profiling data much in the unoptimized build. So I'd probably first start by saying, like, let's at least turn that on. And I could also turn off Handmade slow, so we weren't asserting and stuff. So we had a lot less code happening there as well. And then we can look at the profile, and now we can sort of see a more realistic view of like, okay, in the actual thing that ships to somebody, what would it look like? And okay, that's what it looks like. So now if I come here and I turn on the software renderer, you can now see a more realistic sort of version of how expensive it is to do some of these things, right? And so you can see that now 50% of our time is spent just rendering stuff in software, right? And that's what you would expect, because that's what almost all the time is. So in the actual game, right, in here, amusingly enough, debug collation still dominates the time, which is pretty hilarious, actually. I guess that's because we call pixel fill so many times. I'm not sure whether we would really want to do that. That's probably... let me take that out, because that's generating a ton of things which we probably don't want to generate. So inside Handmade render, I'm going to take these ignored time function stuff, and I'm going to go ahead and actually make them ignored. Oh. Okay. All right, so now I think we won't be spending so much time on that collation. So here's our hardware rendered profile. Here's our software rendered profile. So you can see basically all the time being spent in do-tiled render work, which that is what we would expect. You can see our frame rate is not particularly great. But again, some of that's actually, it's counting having to render all this stuff as well, which so isn't quite fair, because there's a bunch there. This is just a lot of rendering that it wouldn't otherwise be having to do. So that's a little bit, what we could do is do something more like this, right? And then go in here and say pause and scroll back. You can see the difference in the frame times. This is a 24 millisecond frame, 27 millisecond frame, and then you get out to the ones where it's on and it's 45 milliseconds. So it's quite a bit different when you are and aren't rendering stuff in the profile view. This is just a lot of work for render, because all of these are all little texture map fills. If we wanted to optimize that in software, we'd do a bunch of rectilinear blitz type stuff that was highly optimized for fonts or something, so that we could draw this a lot faster. But we don't really care about that, because this isn't really part of it for us. But anyway, so then if we go into the game code here, like so, you can see that we're still, even with that, we're doing pretty good on render time. Should probably clear the screen, but it's pretty good, right? And if you look at what's actually taking the time, it's kind of a little bit odd, to be honest. I'm not sure I really understand why frame display is taking so much time. Oh, well, actually, we did determine this. It's just Windows eats up a ton of our time. Yeah. That actually is Windows being crappy. Why is draw rectangle still being clocked separately? And that's a lot of rectangles. 18,000 rectangles? Why are there 18,000 rectangles? Is that really a reasonable number of rectangles? I mean, there's a lot of rectangles here. And then there's all these rectangles in here. But 18,000 of them? I don't know if I believe 18,000 rectangle draws got called. So these should actually always be timed. All right. 18,000 does not sound right to me. That's weird. I feel like something's up there. We should probably actually keep timing stuff like that and do a little bit of a thing to try and ascertain why so many rectangles are being called. Yeah, that's really weird. Anyway, you can see how long, like, this is just a tremendous amount of time that it takes before Windows actually gets, like, we're done in half the time, and Windows takes a long time to get us to the screen. I don't know if that's because of the VSync or some other weird, because there's a one frame lag, or I don't know what's going on, but it's kind of interesting. Like, we'd actually be hitting 60 hertz right now if it wasn't for this. That's so darn cool, by the way. Yeah. Long Boolean, what does OpenGL do when you enable GL scissor test? It's basically saying that instead of clipping to the window boundary, clip to the boundary that you've specified. Because OpenGL always is actually clipping, obviously. I mean, it doesn't corrupt memory and write into a no man's land. So, you know, here's the screen. Here's the scissor, right? This is whatever you pass to GL scissor. If you GL enable GL scissor test, then it's actually going to use what you pass to GL scissor. Otherwise, it'll just always use the whole screen. So it's basically just saying, do you want this rectangle on or not? I don't even know why they have that, but it's just kind of, I guess, the way OpenGL does things. There's like enable and disable. I would have just said you always have to set the scissor. So if you don't want to scissor that, set it to the whole screen, right? But, you know. All right. I am going to wrap it up because I want to eat dinner, although I don't really know when dinner is. I didn't make it today. So let's see. Close this out here. Handmade. Switch back to debug. And I'm going to go to the to-do list, and I'm going to say, and I think we certainly got logging in there and thread visualization. I want to know what's the deal with 18,000 rectangles? Because I don't know what's going on with that. All right. Okay. thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always pre-order the game. It is available on handmadehero.org, and it comes with the source code so you can play around even as we develop it. We also have a forum site you can go to where you can ask questions, and that forum site will be going down this weekend because we are transferring it over to the Handmade network people. They have graciously offered to maintain it. I don't like maintaining web stuff, as you know. So the folks on Handmade Network are going to be taking it over this weekend. That means it will be unavailable for a couple days while it gets moved over and tested, basically, so that everyone, so that it's not obviously busted or anything like that. So that'll be happening this weekend, so you won't be able to access the forums for 2 days or so. But then next week, the forums will be back as normal. They'll just be hosted on Handmade Network, and I believe they're planning on cleaning them up a bit too, so hopefully the forums won't be so janky. They might be a little bit nicer because they'll be running on a cleaner forum system than the stupid Joomla one that was the one that was running them before. We also have a Patreon page if you want to support the video series, which we of course always provide free of charge. You can do that at Patreon. We also have a tweet bot that tweets at you if you want to when we're going to be live. And the next time we're going to be live will be next week, because tomorrow is the day off. It's Molly Rocket movie day, so we probably won't be around for the stream. That is about it. I hope everyone has a good full weekend of programming. I'll see you back here probably on Monday, but check the tweet bot for the schedule. Until then, have fun coding, and I'll see you guys on the internet. Take it easy, everyone.